The Ice Age was a time of giants. It was an era when the Earth was dominated by colossal creatures, each uniquely adapted to the harsh, frigid environment. Woolly mammoths and mastodons roamed the frozen landscapes, their thick fur and massive tusks helping them survive the relentless cold. Dire wolves and cave bears stalked their prey, using their strength and cunning to hunt in the icy wilderness. But among the most impressive predators was the Scimitar-Toothed Cat, a creature that stood out even among these formidable beasts. This fearsome hunter was not your typical Sabertooth. It was a unique predator with distinct features that set it apart from its more famous relatives. Unlike its famous cousin, the saber-toothed cat, which had long, curved canines, the scimitar-toothed cat had shorter, scimitar-like canines. These teeth were not just for show, they were highly specialized tools for hunting. These blades were serrated like steak knives designed to cut through flesh with ease. The serrations allowed the cat to inflict deep, lethal wounds on its prey. They were perfect for slicing through flesh, making the scimitar-toothed cat an incredibly efficient killer. Its hunting strategy was brutal and effective. The scimitar-toothed cat also had a more powerful build than many of its contemporaries. Its muscular body was built for strength and speed. This combination of power and agility made it a formidable predator in the Ice Age ecosystem. It was a true pursuit predator, capable of chasing down its prey over long distances. Its endurance and speed were key to its hunting success. Imagine a lion crossed with a cheetah, and you start to get a picture of this agile hunter. It combined the best traits of both animals, making it a versatile and deadly predator. The scimitar-toothed cat was a successful predator. It thrived in various environments and adapted to different climates. It lived across North America, Europe, Asia, and even South America, showcasing its incredible adaptability and resilience. But for a long time, we knew relatively little about this fascinating cat. Its remains were rare, and much of its life remained a mystery. New discoveries and technologies are changing that. Advances in paleontology and genetics are providing new insights into the scimitar-toothed cat's biology and behavior. They are giving us an unprecedented look at the life and times of the scimitar-toothed cat, revealing details that were once lost to history. This ancient predator is finally stepping out of the shadows, allowing us to appreciate its role in the Ice Age world. For years, our understanding of was based on incomplete skeletons. These were often crushed or distorted. But recent discoveries of more complete fossils are allowing paleontologists to create accurate reconstructions. These reconstructions are both physical and digital. Scientists use three-dimensional scanning and modeling techniques to piece together the skeletons. Like putting a puzzle together, they can now visualize in greater detail than ever before. These digital models reveal that it was powerfully built. It had strong limbs and a flexible back. Reconstructing the skeleton is just the first step. It's like putting together a giant three-dimensional puzzle, where each bone must be carefully placed to understand the creature's structure and posture. This process can take months or even years depending on the complexity and condition of the fossils. Paleontologists also want to know what the animal looked like in life. This involves more than just bones. It requires a deep dive into the possible appearance, behavior, and environment of the creature. They ask questions like, what color was its fur? Did it have any distinctive markings? What color was its fur? Was it a uniform color? Or did it have patterns that helped it blend into its surroundings? Did it have spots or stripes? These patterns can tell us a lot about its lifestyle and habitat. For instance, stripes might suggest a forested environment, while spots could indicate a need for camouflage in a more varied landscape. While we can't know for sure, scientists can make educated guesses. They use a combination of fossil evidence, modern animal comparisons, and even genetic studies to piece together these details. They do this by looking at modern cats. By studying the fur patterns, behaviors, and habitats of today's big cats, scientists can infer a lot about their ancient relatives. Homotherium likely lived in a variety of habitats. These ranged from open grasslands to colder northern environments. This adaptability suggests it was a versatile predator, capable of surviving in diverse conditions. These range from open grasslands to colder northern environments. Such varied habitats would have required different adaptations, including changes in fur color and thickness, so its fur may have varied. In warmer climates, it might have had shorter, lighter fur, while in colder regions it could have sported a thicker, denser coat. It may have depended on where it lived. The fur's color and pattern could have been influenced by the need for camouflage, temperature regulation, and even social signaling. Some scientists believe that Homotherium may have had a mane of fur around its neck. This feature could have served multiple purposes, from protection during fights to attracting mates. This is similar to a lion's mane. A mane could also have been a sign of maturity and dominance within its social structure. This is similar to a lion's mane. The presence of a mane might have made Homotherium appear more formidable to rivals and more attractive to potential mates. Others suggest it may have had spots or stripes for camouflage. These patterns would have helped it blend into its environment, making it a more effective predator. Whether it had a mane, spots, or stripes, each feature would have played a crucial role in its survival and success as a predator. One of the most exciting areas of research focuses on its behavior. Fossil evidence suggests that these cats may have been pack hunters. At a site in Texas, paleontologists found the remains of numerous. They were alongside the bones of hundreds of mammoths. This suggests that may have cooperated. They may have taken down large prey together. This behavior is similar to how modern lions hunt in groups. Pack hunting would have given an advantage. It would have allowed them to bring down prey much larger than themselves. Further clues to his hunting style come from its eyes. Studies of its skull reveal that it had large eye sockets. This suggests that it had good vision, but unlike lions, which are active during the day, may have been crepuscular. This means it was most active at dawn and dusk. The shape of its inner ear also supports this idea. It hints that it was not as adapted to hearing low-frequency sounds. These are important for hunting in dense vegetation. Instead, its hearing may have been attuned to the sounds of prey animals moving in the twilight hours. Section 6. A menu for a sabertooth. Deciphering the diet of what did eat. Fossil evidence tells us that its diet varied depending on where it lived. In some areas, primarily hunted horses and other large herbivores. In other regions, its diet included mammoths and other megafauna. Scientists can determine the diet of extinct animals by analyzing the chemical signatures in their bones. These signatures reflect the types of plants that their prey animals consumed. This analysis helps us understand the food web. It shows us how fit into its ancient ecosystem. Section 7 versus 2 strategies for sabertooth success. And are the 2 most famous saber-toothed cats, but they were very different predators. With its massive canines and powerful bite, was an ambush predator. It likely relied on stealth to get close to its prey before delivering a killing blow. On the other hand, was built for speed and endurance. Its shorter, serrated canines were ideal for slashing and causing blood loss. This suggests a more active hunting style. May have chased down its prey over long distances. Section 8. The end of an era. The extinction of, and its kin. Unfortunately, like many other large mammals, eventually went extinct. The exact reasons for its demise are still debated, but climate change and competition with other predators, including early humans, likely played a role. The disappearance marked the end of a lineage of saber-toothed cats that had roamed the earth for millions of years. Their extinction reminds us of the fragility of ecosystems. It highlights the impact that environmental changes can have on even the most successful predators. Section 9. What teaches us? The importance of studying extinct predators. The study of extinct predators is more than just a glimpse into the past. It provides valuable insights into the evolution of predation, which is a fundamental aspect of ecological interactions. By examining the behaviors and adaptations of these ancient creatures, we can better understand the dynamics of predator-prey relationships. This knowledge is crucial for comprehending how modern ecosystems function and how they might change in the future. It helps us understand how animals adapt to changing environments, which is particularly relevant in the context of current climate change. Studying these adaptations can inform conservation strategies and help predict how contemporary species might respond to environmental pressures. By studying extinct predators like the saber-toothed tiger or the megalodon, we gain a greater appreciation for the diversity of life that has existed on our planet. These creatures, though long gone, have left behind a legacy that continues to shape our understanding of biology and evolution. We also learn valuable lessons about the interconnectedness of ecosystems. Predators play a crucial role in maintaining the balance of their environments, and their extinction can have cascading effects on the entire ecosystem. The extinction of these apex predators serves as a reminder of the importance of conservation efforts. It highlights the fragility of our natural world and the need to protect it. It emphasizes the need to protect the planet's biodiversity for future generations. By preserving the habitats and species that remain, we honor the legacy of those that have been lost and ensure a richer, more diverse world for the future.